Fluid power practice problems, people. It doesn't get much better than this. You've all received this packet now, and you have some assignments when you have to get certain parts of this thing done. I thought I would take this opportunity to walk through the first problem on it with you so you know exactly what it is you need to do. So it says, problem number 1, a pneumatic system is producing 100 pounds per square inch of gauge pressure. A cylinder is needed to press an adhesive label gently onto a product. It has been determined that 5 pounds of force is the optimal force to complete the task. First thing you need to do is sketch your schematic. So what do we know? Well, we know we're going to have a cylinder, we're going to have some lines, we're going to have a gauge. It tells us about a gauge. We're going to have a pump. And so here's what I got right now. I have a pump forcing the air into my receiver tank because it's a pneumatic system, so it has a receiver tank. Here's my line. I have a gauge. Gauge could appear anywhere on here. It's telling me I have 100 pounds per square inch of gauge pressure. It's feeding into my actuator over here, the cylinder, and there's my actuator drawn very nicely, I must say, and it's exerting 5 pounds of force in that direction. So when you do these sketches, take all the things that are known that they give you in the little scenario and make sure they are in there, okay? Step number 2, what is the required area of the pneumatic cylinder? Area. Well, if we think back to our good friend Pascal, who took my marker, Pascal's law, we draw it up like we did Ohm's law, force over P and A. We're going to solve, which is force over pressure times area. And so what we want to find out is area. So we simply say, well, you know what? If I take that and I'm going to say area is equal to force divided by pressure, pretty simple. Area is equal to what's the force? I need 5 pounds of force. The pressure is 100 psi. If I divide that out, I get a whopping 0.05. So my answer over here is the area is equal to 0.05 inches squared. Okay? So we're using Pascal's law, and you're going to use that over and over again to solve these issues. Number 3, what is the required diameter of the pneumatic cylinder? Well, this one gets a little bit more interesting because we know diameter is 2 times the radius, but we don't know the radius. But we do know the area, and we know that area is pi r squared. So maybe the first thing I got to do is find my radius. So if I say my area is equal to pi r squared, and once we know r, then we're going to be able to figure out our diameter, which is simply 2r. So I know I got 0.05 for my area, and that is going to be equal to pi r squared. And so what I can do next is I will take the 0.05 and I'm going to divide it by my pi, and we are going to use 3.14 for our calculations, and that's equal to r squared. And when I do that, I get 0.016 is equal to r squared. And then I'm simply going to take the square root of both sides so I can isolate r, and the square root of 0.016 is 0.13, and that is my radius. And so now, according to my other formula, all I got to do is take 2 times the radius to get my diameter. 2 times 0.13 is equal to 0.26. And so the diameter of my cylinder is equal to 0.26 inches. Okay? So when you go through these problems, and you already got the first 3 done, that's the format you want to follow. Now, of course, what you have to solve for is going to change. Make sure you do a good job with your sketches. Make sure you put in the formulas that you're going to use. Give me all the steps there, and then your final answer written over there in the proper units. All right? Like I said, fluid power practice problems. It just doesn't get any better than this.